So these factoring trinomials, binomials can be a little bit tricky in this lesson because there's not a strict pattern that every single one of the expressions goes by. So when you're doing this, the best advice I can give you would be for the first thing or the first step you always take when factoring these is always check first to see if you can pull out a common factor. Not only because then would it be fully factored when you're done, but if you can pull out that common factor, your exponents might get smaller, your number values, your coefficients might get smaller, and overall it just might make your life a little easier. So if you look at number 3, if you look at the coefficients first, 4, 16, and 16, and then the variables, z to the 4th, z to the 3rd, z to the 2nd, sometimes you can pull just a number value out, sometimes you can pull just a variable, sometimes you can do both. So in this case, we can pull out the factor of 4 from 4, 16, and 16, and we can pull out z, and that should be squared, to the 2nd. We can't pull out more than that lowest exponent because that's the most that that one has to give. You can't pull out x to the 4th if that last term doesn't have 4 or z to the 4th. If that last expression or that last term doesn't have z to the 4th power. So the common factor, we're going to divide out 4z to the 2nd. So remember when we pull out a common factor, all we're doing is really dividing each term then by that 4z squared. So 4 divided by 4 is 1. Z to the 4th divided by z squared, you're left with z to the 2nd. You can put a 1 there in the front if you want to. It does not matter. And then negative 16 divided by 4 is negative 4. Z cubed divided by z squared is just z to the 1st. And then positive 16 divided by 4 is 4. Z squared divided by z squared is 1. So we're not going to write 4 times 1. We're just going to leave it at 4. So now what we want to do is factor this trinomial that we're left with. So now it's a normal trinomial that you guys know how to factor. This is where you do the first times last. So 4 times z squared is 4z squared. What multiplies to get you negative or positive 4, but adds to get you negative 4, negative 2, and negative 2. So just remember not to lose that 4z squared. It's still part of your expression. It is a factor that needs to be included, but this trinomial can be factored into z minus 2 and z minus 2. Negative 2, negative 2 adds to get us negative 4 in the middle, multiplies to get us positive 2 or positive 4 at the end. So always check to see if you can pull out a common factor first. Then figure out, okay, is it like a trinomial where I use the diamond and box, or is it a difference of squares? Is it a difference of cubes or sum of cubes where I have to do SOAP? But always check to see if you can pull out that common term first. So let's look at another one, number 5. 16z to the 5th minus 250z squared. So looking at your coefficients, 16 and 250, they are both even, so we can divide them by 2. That would give us 8 and 125, and I think that actually is the biggest common factor there. So we can pull out a 2, and the most or highest number of z's we can pull out is z squared, because that's the most that your expression has to give that last term, from that last term. So we're going to pull out 2z to the 2nd as a common factor. 16 divided by 2 would leave us then with 8 z to the 5th divided by z squared. Remember, when we divide exponents, we really subtract them. So 5 minus 2, I told you those exponent rules don't go away, leaves us with z cubed. 250 divided by 2 is 125. So what am I left with now inside here? It's not a trinomial with 3 terms. So is it a sum or difference of cubes or squares? So if I look at 8 and 125, they are perfect cubes. 8 is 2 cubed, 125 is 5 cubed. So I'm just going to carry the 2z squared down, so I just don't forget it. But now we're going to have to use our SOAP. So I always start with the baby set or a small set of parentheses and a larger set. It's the same sign, opposite, last one's always plus. So that first set of parentheses, you take the cubed root of both your terms. So the cubed root of 8z cubed is 2z. Cubed root of 125 is 5. So once you have those two terms, 2z and 5, all you do is square them and then multiply together. So 2z squared, 5 squared, 2z times 5, and then you are done. So you're sort of ignoring what the signs are once you've put them in to your parentheses. So I know that in that first one, it's 2z and negative 5, but we don't take that into account when we do that middle term in the second set. Take the cubed root. Once you get those cubed roots, square them, multiply together. So let's look at number 7 yet. So we still want to check. This one's kind of weird because you start off with two terms again. But if you're looking at 1681, they're not divisible by 3. 3 doesn't go into 16. 4 doesn't go into 81. Not divisible by 5 or 6. These don't have a common factor, and because only one of them has an x with it, you can't pull out a variable either. So what we actually have here is a difference of squares. It just looks a little weird because of the x to the 4th. But you guys know that the square root of 16 is 4, and the square root of 81 is 9. Well, normally you would be trying to get to an x squared, so we would put x and x here. But if we're trying to get to x to the 4th, what times what would give you x to the 4th? Well, that would have to be x squared and x squared. If we have no middle term, one is plus and one is minus. So we just have to check and make sure we can't factor this just a little further. Because I'm looking at 4 and 9, and it might not trigger in your brain right away, but 4 and 9 are perfect squares. So we do have a difference of squares here yet again. We can't factor the sum of squares because nothing's going to multiply to get you positive 9 and add to get you 0. It either would have to be negative and negative or positive and positive, and that would either add up to negative 6 or positive 6, so we'd end up with middle term. So we can't factor that further. But 4x squared minus 9, we can factor that into 2x and 3, 1 plus, 1 minus. We just took the square root of those guys again. And now we can factor a linear 2x plus 3 and 2x minus 3, and the 4x squared plus 9 stays. So again, not always straightforward patterns for these. You just kind of have to take it step by step. So just always remember, pull out a common factor first. You might be left with a regular trinomial where you can use the diamond. Otherwise, you're probably left with a difference of squares or cubes or a sum of cubes.